It's my pleasure. Hello. Hi, it's my pleasure to have introduce Chris Bale for our lunch talk today. Chris is I guess you're still assistant, though barely. We're fixing that. I'm a professor of sociology at Duke. Most recently, we were able to steal him for the lighter blue shade of the campus in the area. Chris is a remarkable data scientist working in sociology at the edges of questions of networks and culture and politics. He has a remarkable book on
Terrified.
Terrified. Yeah. I was going to say terrorism as well. Terrified, where he traces the sort of debates about and rhetoric around Islamic terrorism across lots of different settings. And in the process of doing all of this work, he's developed a remarkable suite of tools and approaches to scraping data and dealing with complex, ugly data. It's like free-form text and blogs and these kinds of things. And since our world in the network sense is moving so much more in this direction, I thought it would be great for Chris to come in and tell us what he's working on. And his own work is also related to health, including work on autism and autism support groups. So I was really looking forward to being able to do this, and thanks a lot, Chris.
Thank you, Jim. It's a pleasure to meet all of you. It looks like you've been getting a kind of a fire hose of R all morning, and I would like to say I would like to slow that down, but because I have such a short amount of time, I want to try to cover a lot of material. I'd like to introduce first a kind of a basic overview of the types of data that are out there and how you might get them, specifically two popular approaches. The first is, often referred to as screen scraping, and the second form that I'm going to argue is probably going to be more attractive to most of you, depending on what you're working on, which is called an application programming interface. So, as Jim mentioned, we're in this remarkable moment where network data is just the internet is just teeming with network data. More data was collected in 2012 than all previous years of human history combined. A lot of this data has a graph structure because it comes from the internet and was generated by social media, though really some of the more exciting work is with administrative records now too, so that this kind of text data revolution isn't just limited to the kind of more recent phenomena of the internet and social media. We can also go back and generate really great network data with historical case studies. And third, this is really interesting to network folks because a lot of the data is dynamic. We have, an uncommon amount of data over time, often down to the millisecond. Multiplex, meaning it captures multiple dimensions of social relationships. And weighted, meaning that, we can describe different strengths of relationships between people. So these are all very new and exciting things, especially in the world of health, but in other domains as well. But I think the first question to ask yourself before, if you're thinking about diving into this, is do you need to collect data? Now we're all here I'm here to tell you how to do this, so I don't want to kind of dissuade you, except I do want to give you a sense of what's involved and tell you first that there's already been a vast amount of network data that's been collected and compiled. I've been keeping a list. You can visit at this link. There's just a massive amount of stuff from, Jim mentioned stuff on blog posts, but, there's also Yelp reviews, Netflix data, a variety of repositories of network data, at places like Stanford and Irvine. So why might you want to use someone else's data before getting your own? Well, this morning it looks like you began to be exposed to these awful, horrid things called lists. Well, you deal with a lot of lists, and you deal with a lot of strange formats. For example, what's known as JSON data or XML data. And if your background is in, say, SAS or Stata or SPSS, these are going to be very new and unfamiliar. They're not necessarily difficult to work with, but you do need a new set of skills. And I'll give you a very kind of general overview of how you might work with these types of data and extract network data from them. But there is a bit of a learning curve. And finally, you need to be able to parse all these data into an edge list, an adjacency matrix, something that you could actually use to create network structure. So these are each significant challenges. I will say, though, that in my experience, learning this stuff is about 95% effort and endurance and 5% smarts. Often the reason why one fails is simply because there's a lot of domain knowledge about how a particular website works or how a particular function works in R. And though many of the people discussing the function on the internet or a site like Stack Overflow, where you might go to get information about an R function, or I'll explain in a minute. Have you covered R packages yet, Jake? Is Jake here? Yeah. Okay. But the point is, if there's a problem, it's probably not you. It's probably R and the R community, and that's why I encourage you not to get dissuaded by these steep issues. Okay, so you still want to get your own data. As I mentioned, there's two popular approaches: screen scraping and application programming interfaces, and I'm going to spend most of my time on the latter, and I'll give you a brief taste of screen scraping and why you might want to avoid it. Before I get into the details, I want to give you this link, which includes not only these slides, which have a lot of clickable interfaces and some links to websites that will be useful, I hope, but also some annotated code, which means a .r file that you could open in RStudio with comments that explain what I'm doing in each line. And the reason that I provide you with these, as everybody is going to this link, is so that you don't have to go to this link right now, and later you can. So what I encourage you to do actually is to follow along at a very basic level and try to shut off the part of your brain that says, learn how to do X in R, learn how to do Y in R, and instead try to learn how to learn, by which I mean try to focus on where you need to go to get the type of information you're going to need later. Because as you'll see, if Jake this morning showed you a lot of different ways to skin a cat in R, that only gets more and more complex as we move into the area of scraping data from the web. Please feel free to interrupt me. Again, I'm going to try to keep it at a very general level, so if there's technical issues, I'd be happy to talk afterwards or via email. I'll give you my contact information at the end, but if anything's unclear, please feel free to stop me. Okay, screen scraping. So once upon a time, you could scrape just about anything from a website. Any website, you could write a small piece of code and grab all the data on the website. That's more or less true, especially in the early days of the internet. Unfortunately, we're no longer in this kind of wild, wild west situation. Screen scraping right now is against the law for many sites. You can find out if it's against the law by reading what's called the terms of service, which is a very, very boring, long legal statement at the bottom of a website, and it's also something we agree to when we sign up for a site like Facebook or Twitter, and no one ever reads it. But in many cases, even simple, honest, small amounts of data collection are technically illegal. There's some gray area, but I encourage you to take it seriously, because if you invest all the time to getting the data, there's been a few high-profile cases, for example, at the University of Michigan, where people went to quite a bit of effort to get a large amount of data, and then lawyers shut them down, and they weren't allowed to publish with it at all. So better to talk to your IRB officer before you begin this type of work and make sure you're on firm ground. I will say, though, this is new ground for IRB, too, so they really don't have a good sense of what's kosher or not yet. And sometimes you have to find your own way. So what is screen scraping? Screen scraping refers to a type of computer program that first reads in a web page, takes the data from the web page. Usually you want to find some information on it. For example, edges that might connect two people, since we're talking about networks. There could be a bunch of other stuff. Grab that information, and then usually you want to store it in a data set or a data frame, to use the language of R. So this is a site from Wikipedia, and you're all familiar with the format of Wikipedia, but if we look at what a computer sees when we look at this website, it's much messier, right? And though we're getting really good at recognizing images and so on in digital data, especially due to some work of folks here at Duke, most of the time, and certainly unless you're going to get into some really sophisticated programming, you're going to be dealing with data that looks like this. This is HTML data, and essentially what this is doing is it's telling your web browser how to visualize something. So, there'll be links to pictures, they're stored on a Wikipedia page, there's a bunch of stuff that says, make this title bold, make this text smaller, and so on and so forth. And if we want to get some small piece of information from the page, we need to learn how to read through this very complex and often very, very long mess of text and find the data we want. To do that, I recommend a package in R that's called rvest. I think I heard Jake mention DeepLiar earlier this morning. And DeepLiar, this is another package written by Hadley Wickham, who's a somewhat famous R developer that builds upon, this isn't really important, but a Python library called Beautiful Soup, which is one of the more popular programs for scraping data. So I'm not sure if did you cover like installing a package or okay. So what you'd want to do is kind of install a package like rvest. There's many others, by the way. There's offhand I can think of 6 or 7 pretty good packages, but rvest handles a variety of types of data. It's a little easier to use, so I recommend starting there. And basically you'd load it into R's memory, and the first thing you'd want to do is actually grab all that very messy text data. And Jake was just telling you about functions. I'm going to be showing you a lot of code chunks, so this is what would appear in your RStudio browser. Occasionally the text is going to get cut off because I had to make a trade-off between letting you actually be able to read it and then fitting it all on the page. But what you'll see here is HTML and then parentheses, and that's defining a function called HTML within the rvest package. And what that function does, Jake showed you how you can get into the source code. So if you wanted to, you could type in after loading rvest and running that library command, you could type HTML and see what it's actually doing. What it's, in a very general sense, what it's doing is just reading in all that data. So what I've done on this top line is said, use this HTML function to define a new object within your R environment. It's going to be called Wikipedia page, and as you'll know, this caret indicator indicates that everything on the right side, so this HTML function, which should be over here, is being defined as Wikipedia page. So then if we run that line, if you just highlighted Wikipedia page and hit Control Enter, then you'd see all of that kind of messy text data that I just showed you. The next trick, which is time-consuming, and one of the reasons I generally discourage you from working with screen scraping, is to find the little piece of code that stores the data that you want. And that is just a pain. So what you'd need to do is use a combination of tools with it that are from rvest, and I often use what are called the developer tools within the browser Chrome, though there's analogs within other browsers. And these essentially let you hover over a part of a web page and right-click on it or click on it depending on the browser, and then it tells you, it'll show you the code on one side of the page, and then it'll show you the object you're looking at on the other side of the page, and it'll help you find that piece of code where it's stored. If you're dealing with so if you're dealing with Wikipedia, it'll be something called an XPath. There's another way of doing this that involves something called CSS. It's another type of formatting for web data. But basically, in a very general sense, this is a small, usually a term or a set of terms, sometimes defined by brackets. It's a little chunk of code that tells R and the rvest package where the data that you want lives on that messy page. There's another tool I recommend, a plugin for Chrome that's called the Selector Gadget, if you really get into it. And again, the annotated code that I linked to at the beginning of the page will actually take you all the way through an example of how to do this. So I encourage you to kind of just follow along at a very high level for the time being. So sometimes this is really not that hard. A site like Wikipedia actually wants to share its data with the world. And so Wikipedia sites are structured in a very consistent manner that's relatively easy to parse. And by parse, I mean get that piece of information that you want off the page. More often, this is not a piece of cake. And there's a few reasons for that. Most websites use a variety of different HTML structures precisely because they don't want you to get their data. And again, it might be illegal, so it might be a bad idea in the first place. And each time you encounter a page that has a different structure, you need to find that little piece of information that tells R where that information you want lives. So suddenly you get into a world where, let's say you're dealing with 10 different websites and you want to get 10 similar pieces of information. All of a sudden you're going to have to spend quite a bit of time digging into each website, figuring out how it's structured, and then finding that little code that I called an XPath or a CSS object that lets you find that piece of data. And so you pretty quickly begin to get into a world where you might want to think about either collecting that data by hand, as crazy as that sounds, or using a crowdsourcing tool like Amazon Turk or Mechanical Turk, or some type of undergraduate slave labor. There's other things that can happen when you try to scrape websites. So, sites such as Google, for example, have very sophisticated infrastructure that count how many times and how frequently you're requesting data. So if you trip one of these systems, then you'll pretty soon stop getting access to the website. Google, if you were loading it in your web browser instead of R, would tell you something like, are you a robot or not? Has anybody experienced this? Okay. So here's an example of a type of web page that is just a real pain to scrape. I'm going to work through an example with Twitter later, so I thought it would be useful to try to grab a sampling frame that we could use to grab Twitter data, and forgive the silliness of looking at celebrities. But let's just say we wanted to get all of these Twitter handles here, and then later on, in about 15 minutes, we'll use those Twitter handles to generate a network using some other tools. Well, to do that, we'd have to go through the HTML for this page, which is about 20 times as long as that Wikipedia page, in part because it's fancy, right? It's got all these buttons and hover things and, images, different types of frames, and all of this requires a lot more code. But more importantly, the owner of this website doesn't want us to get this data easily. Otherwise, we could make our own website that counts the top Twitter trends, and then we'd be competition for this website, right? So believe it or not, even though I've been doing this for about 10 or 12 years, it took me about 15 years to discover that what we needed was this small little chunk of text called .name bio, and if we pass that as an argument within our vest, we can then get what's called a table, which is a part of the HTML file that contains all of these handles. And I had to do that using a combination of essentially tricks, using the developer tools in Chrome and using that plugin called Selector Gadget. And basically both of those things, you can interact with the web page in various ways. As I mentioned earlier, the Selector Gadget has some more sophisticated tools to do this. And then you can find the data. But it takes a lot of time. So we found what we want. We can read in the file with the HTML command, or the HTML function. We use a separate function called HTML_nodes, and what that does is it recognizes parts of the HTML file. So an HTML file is structured kind of like a tree, and what you want to do is figure out which branch the data you want is on. And we know, thanks to all the work I just described, that again is detailed in excruciating detail in that file that I linked to at the beginning, and I'll link to at the end again, tells this HTML command, HTML nodes, where that data lives. So I grab that part of the HTML page with this command, and then I turn that HTML into text data in an object called names. Because remember, my goal in this silly example is to grab the names, the Twitter handles of all the people that we're gonna look for on Twitter later. And here's what I get, right? Hardly the perfect, neat data frame that I might want, right? What I've got here is actually a list, right? These are these, well, you might not have gotten into it with lists, but this is why you want to learn how to work with lists in R. You've got to learn how to tell R that you want this, but not that, and definitely not that, and you want to do that in an iterative fashion. Otherwise, you're going to be doing this slowly all day. And again, you might have been in better shape, honestly, going through and hand transcribing that data, right? So there's some tricks, a variety of tools for text in R, generalized regular expressions, and that can help you, slowly work through in an incremental way. And I'm rushing because it's painful, honestly. And once again, I've got a list, so I've got to unlist the list. I've got to get into characters, and finally, I can create. Sorry, I didn't show you the beautiful outcome here. But finally, I can create a data frame that includes the Twitter names and the Twitter handles. I'll show you that in just a second. We'll work with it in a sec. But this was all meant to show you that it's just a bit of a pain to get this data in this way. All of these commands can be placed within loops. So, if for example, let's say we wanted to get a bunch of network data that lived on a set of Wikipedia pages, say, for each country or each, elementary school in the US or something like that. That would be a fairly good use case for screen scraping because we can fold all that into a loop. Did you cover loops yet, Jake? So a loop is essentially, many of you, who's used a loop before in Stata or Seth? So generally, many of you will know that it's a way of iteratively doing something again and again and again. In this case, what we would do is we'd get a list of the websites we wanted to scrape. We'd put them into a loop in R. I don't have the example. We'd put them into a loop, and each time we'd pass through and change the name of the website we want to scrape it, extract the information, put it into a data frame, and repeat. And that way we could slowly and incrementally build our data set. But again, imagine that we're not dealing with a consistent HTML structure, and we're dealing with, especially if we're dealing with more than one type of website, this is just a recipe for disaster. And again, you may run into what's known as rate limiting, and that is if your loop asks for too much information too fast, even from a generous site like Wikipedia, Wikipedia doesn't want you to make too many requests because it slows down other people's access to the data. And so if you eventually get into this world and start writing loops to do screen scraping, and R starts telling you about SSL or OAuth errors, that means you've tripped these types of rate limiting features of sites, and you need to go read the terms of service. If you get really into this, there's ways of figuring out what you're allowed to do and not allowed to do. You have to kind of enter the language of computer developers to do this and read about what's known as rate limiting. I'll talk a little bit more about that when we get to APIs, but there are ways of doing this in a systematic way, and if there are sites like Wikipedia or, for example, the Internet Archive that again want you to be able to scrape their data, then this is not too difficult. So again, the ideal use cases are sites like Wikipedia or Internet Archive. These are sites which are expressly in the public domain. A second good use case that I found is older websites. So a lot of you are working on health, older government websites of, say, Department of Health and Human Services, right? The U.S. government is reliably 10 years behind in any dimension of technology, right? So that's also true often in terms of HTML. And what's nice is they don't yet have all these new tricks that prevent you from getting the data, but they also often have a very consistent structure, right? You might want to get the data from 1997, and then the next page is 1998, and then the next page is 1999. And as long as the web pages look similar for each of those things, it's not too hard to write a program that could get that type of data. Or pages that simply host a lot of data. So sometimes, these kind of messy internet pages that just describe the names of files, those are also a pretty good use case for screen scraping, because you can easily write a program that says, go to this very simple web page, get a list of the files on that web page, and then slowly scrape each one of those files. When not to use screen scraping, I've already mentioned that it's often illegal. When you want to collect a lot of different information from a lot of different pages, and there again, consider crowdsourcing or RAs. Or, and this is the most important reason, I think, when a website has something called an application programming interface. And before I get into APIs, or application programming interfaces, are there any questions, just general questions about screen scraping? Yeah, Jim.
Just out of curiosity, does the RVest tool or any of the others that are built into R have the ability to walk through HTML links? If I started at nih.gov, will it then take me to the next HTML and just follow down as far as it goes?
It's certainly possible to recognize hyperlinks within the HTML structure, but unless they're formatted in a way that says something like next page, it's a little tricky. But you know, it's kind of a neat use case of something like respondent-driven sampling. If you give it a seed website and then spider out, that's definitely possible. The rule that would have to be followed, though, is get all the links, follow all the links, and repeat. You know, you could get into a world where you use some type of fancy natural language processing to try to define which types of websites you want in your sample and not, but that's really advanced stuff. Yeah, good question. Was there another hand over here? No. Okay. So what on earth is an application programming interface, and why should we care about them? An API is simply a manifestation of some general shifts in the internet, I would argue. Once upon a time, we all kind of went to one website and got one type of information. Now, most of the time that we use the web, we're actually experiencing a lot of data mashed together in different formats. So if we go on to Facebook or Twitter or Google+, anybody use Google+? That's the only joke, sorry. It's a bad one, too. We're often, right, experiencing data that's coming from all over the place, right? Your friend might have shared a New York Times story or a Fox News story or a video from The Daily Show, or a link to another website where you can get another type of app to plug into your Facebook page to do something else. And that's because this moment in the internet about 10 years ago, when we kind of moved from Web 1.0 to Web 2.0, meaning that the internet really became about sharing data broadly. And what happened is, just as a lot of these sites were starting to do this with their data, to guard it very forcefully, again, because people were starting to realize that data was valuable, right? The owner of that top Twitter page realized, oh, if I make this really easy to get, someone's just going to write an automated program that gathers this data every day, make their own page, I'm out of business, right? So that happened, and people started to, for a variety of other reasons, Silicon Valley started to guard its data. Some of them, by the way, related to issues around IRB. It's kind of our fault in some ways. Sometimes it's their fault. So for example, AOL famously released the personal search histories of millions of people, which might seem innocuous at first until you realize that people also Google themselves, and then you can tell exactly what someone's Googled. So huge, huge legal headache, right? And so data became a very precious and private thing during this period, you know, mid-90s, late 90s. But then another thing happened, which was essentially that sites like Facebook or Twitter, which weren't around yet, but other sites began to realize that to survive, they had to create this type of functionality. So people wanted a single user experience where you could bring in all sorts of different types of data. Nobody wanted to go to the New York Times and then to whatever to get all the information that they wanted, right? So this was around the area when application programming interfaces came into existence. And an application programming interface is simply a type of tool on the web that allows someone, usually a computer developer, but it could be social scientists like me, to make a custom request for a large amount of data again and again and again. And so basically what this does is, instead of having to go to a website and navigate all this junk, the website actually makes it really easy for us to request a very particular piece of information, extract it, and put it right into a data frame. That's why we like these. We also like them because they're not illegal, and because they're just generally quicker and more seamless to work with, particularly if you have a really large data collection task. The other reason APIs are great is that there's an API for just about everything now. Any really large website, almost all of them have an API. Google alone has dozens of APIs, maybe hundreds now. And this graph here shows the just remarkable outgrowth in APIs. And though you might think of them as just, social media data or something like that, now every website has realized that in order to be shared on social media, which is the goal of most people who are trying to produce information on the internet right now, they too have to build an API that can then send their information to Facebook. So because we all share articles from JSTOR in our Facebook feed, JSTOR had to, pity on them, had to build an API. But likewise, Medscape, Archive, pretty much every big scholarly repository of information, and then things like Google Maps, Google Translate. And so what it's done in this really brilliant and fascinating way for those of us who are getting into this world of computational social science is open the possibility to construct your own data set completely on your own, with remarkable detail and with remarkable breadth and depth. For example, by matching Facebook data with Google data, with Twitter data, or so on and so forth, with really unprecedented, again, longitudinal detail. But also, everybody talks about big data, but I think it's also enabled a kind of sort of wide data. We have like many more variables that we can throw at stuff. And again, I urge you not to just think about this as the internet, because increasingly we're seeing, sites like Google digitize every book in the English language. And those are available through APIs. So think broadly when you think of an API. If you're looking for a lot of information that lives on the internet, it's probably easiest to get it from an API. So let's look at an API together. This one is from Facebook. And what this tool is this is what's called a sandbox. It's essentially a website that lets us play with some data. And what we're doing here is we can make requests here for different types of stuff. So I'm going to request myself here. And then I'm going to request my friends. This is always dangerous. And some of you know Akeem, so let's pick on poor Akeem, his former postdoc at Duke. And then, so now I've got Akeem here, and I can grab Akeem's friends. And what I can't do is then grab Akeem's friends' friends. And the reason for that, it tells me there's no data. The reason for that is this thing up here, which is called an access token. And that's, think of it as like your access code. And what that code does is it tells Facebook what data you are allowed to get and not get. And most APIs have some type of access code, key, token, there's all these kind of words associated with them, or credentials. And what that means is that you're trying to get, the website knows what you're allowed to get. Now, in some cases, it could be defined by issues of privacy. In others, it could be, have you paid for a service? So APIs can not only store data, they can also analyze data. So for example, let's say you have a lot of PDF files that you want to do optical character recognition on. You don't want to spend hours doing it in Acrobat. You can pipe all of your PDFs up onto an API. It will analyze them and spit them back as a neat data frame. There's even tools for like natural language processing. So if you've ever heard of topic modeling, there's APIs that will take your data and run topic models and spit back the results. You don't have to learn any of the nitty-gritty in order to do this. So in other words, yet another reason to learn about APIs is they allow you to access a lot of new tools for things like, even things like visualization by processing things on a remote server. Okay, so this is Facebook. We could go on and look at, I study, as Jim mentioned, some public health advocacy organizations. One of the ones I work with quite a bit is called Donate Life. I could get their posts, I could get their friends, down to the very timestamp here. Earlier I mentioned JSON data. This is what JSON data looks like. And essentially what's nice about this, though it may look similarly messy to the HTML data we were looking at earlier, things that are in quotes here, I can index in R using the atomic operator, this little $ sign thing. You must have got into that when you were talking about difference, right? So basically, it lets me neatly parse through all this stuff in a very intuitive way. But I promised you an example from Twitter. Let's see if I can get back here quickly. No, it's not going to let me. So let's look at what Twitter would look like. So here's the other great thing. There are packages that let you interface with APIs. So there's a Twitter package, there's a Facebook package, there's a Google Maps package, there's an archive package, there's an open science package, there's a New York Times package, mostly because so many social scientists are working with these data. And what these packages do is save you the time of learning the idiosyncratic language of each API, which is the downside of working with APIs, by the way, and do them kind of fairly simply. So people write functions, not unlike Jake was writing this morning, to do something that seems relatively simple that might actually be pretty complicated. So we could load a package like the TwitR package. Lots of R jokes, folks. But first, again, we'd need those credentials. We need that code that was at the top of the screen there. And to do that, it depends on the API you're working with, but you often have to think of yourself more as a software developer than a social scientist to get these so-called credentials. So in the case of Twitter and also Facebook, you have to go to Twitter's developer website, and again, this is all linked in these slides that you'll receive in the annotated code, and then develop an account. You need to give them their phone number. It's a bit of a pain. And then you create an app, and you have to give it, a description of what it is and all this kind of stuff in kind of step-by-step form. But then Twitter will eventually generate for you a page. Your app is official in the minds of Twitter. And the reason why you have to do this, by the way, is so Twitter can know how much data you're requesting. You have a digital identity that it uses to tell you to stop or uses to know when you've collected too much data. And it has, I've written over my own code here, but you can get these codes. For Twitter, for some god-awful reason, you need 4 of them. And that TwitR package that I mentioned requires that you pass those 4 really long, what's called a string variable, a character vector, meaning just a lot of letters, usually. And you pass that into the TwitR package as follows, using a function that's called setUpTwitterOAuth. And you pass to it all these different funny-sounding things, tokens, secrets, etc. And what that does is it then generates, it's actually generating a URL that then, you could think of it as being posted into your web browser, and then it's designing it in a very specific way where it pastes together these different text fields in a certain format. You could write these functions yourself, but it takes a bit of wherewithal and knowing the specifics about APIs. I was hoping to get through an example where we would work through one together. I don't think we'll have time to get to it, but again, it's in the slides. And many of you might be just fine working with the package. So we could then, within the package, use a variety of other functions that the author of this package wrote to get data. So Duncan J. Watts, is a very active Twitter user, also a famous network theorist. So we can go through and let me just pull up our studio here. We could do it together, and check out Duncan's network. So if first I'd have to install the Twitter package. Then I'd have to call it using this library command. This getUser function, which I just ran by hitting Control-Enter, then tells this program that I want to look for Duncan. This line gets his tweets. You can see that little red thing that came up here. That was R talking to the internet. It might have taken a lot longer if there were more tweets. And here's his tweets in the console down here. These are the last few tweets that, again, we could probably embarrass Duncan if we had more time. But we're all here not so much to get the text, right, but the network data. And Twitter is great for this because we can get all of the people that Duncan follows and all of the people that follow Duncan and generate network structure out of that. And usefully, we can do that with one command. This line right here, user get friends. Some of the syntax here is a little complicated. One of the downsides of R being so open source and flexible is there's different conventions to do the same thing. And so you kind of just have to either decide to learn one package well or just master them all, which is a lot of work. But sometimes you just have. That's why annotated code, like I've tried to give you, is really useful. But if I run this line here, now you can see R is talking to the Twitter API, pulling down all of Duncan's friends. It's done now. I've created an object you might not be able to see down here, sorry, called friends. And unfortunately, friends is a very unfriendly list. Friends. But, and I'd have to parse through that again, except that this Twitter package also has a function called, I don't know why it's called this, TW list to DF, which stands for list to data frame. And I can just run that one line, and all of a sudden I've got this nice data frame that describes each of Duncan's followers. It's just loading here in just a second. And a variety of these are variables at the top here. I don't know why it's taking so long here. We can see all of their names, the date they joined Twitter. I think my R is crashing here. Sorry, folks. Believe me when I say you could get this easily. Okay. Okay. Only have a few more minutes, and I would like to leave some time for a few quick questions. So I'm just going to kind of speed through here and say that you could also, for example, find out how much data you're allowed to get using some functions in this package. And then in these final slides, I show you how to fold all these things into a loop. So remember we had that big list of Twitter followers, and we wanted to generate what's called an egocentric network around these folks. Well, I can create a blank data frame, and then this is what a loop looks like. And essentially what I'm doing is using these different commands I just showed you in combination to stitch together. Each time through, I start with getting the name of someone whose Twitter handle we scraped. I get their friends, I get their followers, and then I stitch them together into an edge list again and again and again, about 100 times. This would take a while because thanks to Twitter's rate limiting, I had to tell R to rest for 60 seconds. That was Barack Obama's fault, actually. So he has so many darn followers. And so then I get a data set, which I don't think I put this in the Google Drive folder I sent you, but if you'd like it, feel free to email me. So as I mentioned, there's lots of different other packages that you can use to work with APIs. Many of them can be installed from within R. Sometimes you have to use a code repository called GitHub, G-I-T-H-U-B. There's an R package called DevTools, D-E-V-T-O-O-L-S, that you can use to access data from GitHub. GitHub's good to know about because if a new website comes out or a new API, often the code is going to be on GitHub before it gets into R. And there's only a few intermediary steps to learn how to interface with GitHub to get those packages. But otherwise, once you get them from GitHub, they act in just the same way. Yeah, John. Sure.
Chris also has a GitHub account, and
That's true.
And you can be a follower of Chris's, and Chris can be sort of a guide to this universe of his GitHub account.
Sure enough. Thank you, John. So one little last thing, because so many people will want to probably deal with dynamic data, this is a real pain in a lot of these data. So you might get a timestamp that looks like this, and you might want to then transform that into a day or a month or a year. And I'm just, in these last few slides, the previous slides I just sped through, I was showing you how to write your own custom function to work with an API. But here I'm showing you how you would handle dates and parse them into time units that we might normally deal with. As John mentioned, I have a GitHub page that has all of the slides from a whole seminar I teach on this stuff in our department. The slides encode from this lecture in a different Google Drive folder here. And I routinely post new information about how to collect data from the internet using R on Twitter, which in general, though, I think a lot of people think of Twitter as a frivolous kind of thing. In this world, it's actually the space where new information comes out, and it will also help you accumulate slowly that domain knowledge that I argued at the beginning is really critical and hard to get. So that's all I've got. I hope, I don't know, there might not be time for questions. It's already 1. Okay. Sorry. No questions. Sorry.
Questions for Chris?
Just a couple of things I've run into. First thing, there's an ACS package, what the API for the Census Bureau, and that is for health research is both very important. Several of the big health institutes have various collecting health data. The other thing is that IRB can be a real problem with some of
It will depend. It'll depend on the journal. I mean, there's always alternatives. So, like with Google, there's Open Streets, which I use as an alternative for things like geocoding, which means taking a location and then getting the latitude and longitude from it. But you're absolutely right. I mean, it's kind of unexplored territory. Thankfully, I think by and large, or Google isn't tracking us down and saying, you can't do X, Y, or Z. I think mostly because we're small fish, but also because thanks to this new technology, they're able to limit our access in significant ways. So, I think the other nice thing about an API is you kind of formalize your request. You're saying, I am so-and-so, I want this data, and Google can tell you yes or no. But you're right that technically in their terms of service, storing Google data is illegal, yeah. But matching it to your own data set and then storing it, is that this is where the gray area comes up. Yeah. Any other questions?
Awesome.
Okay.
Let's clear our lunch stuff, take a quick break, and we'll come back for the next set.
Cool.